Okay, so in this video, we are going to discuss domain and range at the Algebra 1 level. Now, I can see that domain and range may seem a little random right now, but if we introduce it to you now, by the time you have to know it for Algebra 2 and beyond, you will have a good working idea of what it means and how to write it. So the domain of a function is the set of all possible inputs, the set of all x's. And the range is the set of all possible outputs, the set of all y's that you could get. And there are a couple different ways to write this designation, to write this interval of what constitutes the domain and range of a function. You can use inequality notation, or you can use interval notation. Now, interval notation and inequality notation share a common notation, and that is our famous open circle and closed circle from graphing inequalities. So an open circle, we know, means that the number, the value associated with it, is not a part of the solution set to the inequality, that the number in question cannot be one of the solutions that makes the inequality true. You denote that in interval notation with parentheses. Likewise, that brings us to the closed circle. Closed circles in inequality notation represent less than and equal to, or greater than or equal to. That means that the number in question, the value in question, will make the inequality true because it's on the interval. It's a part of the solution set. And that is denoted in interval notation with brackets that look like this. So now let's translate this to a delta math problem. So here we've got a delta math situation here. We have a function and they want us to determine the range of it. Okay, so the range of this function is the set of all possible y's. So here we're looking at the lowest point, which is -7, and the highest point, that is -2. So let's see how we would write this. So you can see that I've set up the interval. Let's talk about the inequality notation first. So it's obvious that the endpoint of the interval matches the same depth as the lowest point on the actual graph. And likewise, the endpoint at the upper end matches the highest point on the graph. I need to warn you that in delta math, they trick you sometimes, so I need you to be careful. Sometimes they put your starting point here, but your high and your low point will be not associated with the endpoints of the graph. Very important thing to remember. But in this particular case, you can see that they're both included, closed circle, point on the line. So our low point's -7, so we start with it. Our high point is -2, so we end with this. You have to have the letter Y because we're talking about the set of all y's, the range. And then, of course, because everything is included on the line, we use our less than and equal to signs. So now let's translate this over to interval notation. Once again, close circle, equal to. So I'm going to use brackets. And your lowest value always gets written first, and your highest value gets written last. Now let's do the same thing with domain. So this is a good one. Here, they're asking us for the domain of a function. So here we have our low point on the graph is -2. That's our lowest x value we can have. And our highest x value is at x equals 9. And I want you to note something super interesting. So we're going to be going from -2 to +9. And we're looking for x's, right? We're looking for the domain of the function. So this circle is closed. So that means that -2 is part of the solution set. -2, that coordinate is on the interval. So I have to use my less than or equal to sign. But look at this circle over here. This circle is open. That means that +9 is not on the interval. It's not part of the solution set. So I will only use a less than on that side. So now let's translate this over to interval notation. And we see that we have an included low value of -2. So I'm going to put a bracket and -2. But our upper bound, +9, is not on the interval. So for that, I will put a 9 with a parentheses. And just to let you know, a couple of things extra. The infinity sign is never used in inequality notation. And an infinity sign is only used for interval notation. Okay? So if you're going to use the infinity sign or negative infinity sign, it is only used in interval notation. Thanks so much for listening. See you in the next video.